In this video, we're going to be looking at generators. We're going to be looking at motors versus generators, some of the similarities and differences between them. We're also going to talk about, we've already talked about alternating current in our previous chapter, but we are going to go back and revisit what that is. Now, when we were building circuits, we were using direct current. Direct current is when the charges in the conductor flow directly from one terminal of the battery to the other. It means they only go in one direction. Okay? Now, I just drew this to show that it's only one direction, but they would actually go from one side of the battery through the circuit to the other side. But in alternating current, AC, the flow of the charges changes. It's constantly going back and forth. So the charges don't really go anywhere, they just keep going back and forth in place. So what they do is they transmit the energy of their motion rather than actually move from one point to another. Now, the electricity we use in our homes is alternating current. So when we get electricity from the power lines, it's in the form of alternating current. Now, you might have an electric generator at your home. An electric generator is something that changes mechanical energy into electrical energy. Okay. Now, mechanical energy, we talked about back in chapter 5. Mechanical energy is the sum of kinetic energy and all forms of potential energy. So, the kinetic energy part is what I'm getting at here, but it changes motion into electricity. So for instance, a hydroelectric generator, like the Hoover Dam for instance, is able to use water to turn the blades of a turbine, which generates electricity. Coal and natural gas generators burn fuel, which ends up causing a turbine to turn, which generates electricity. Now, I want you to understand something here. Burning fuel technically is a chemical change, but the burning fuel is not what gets changed to electricity. It's the turbine turning that generates the electricity. So the key part is the motion of the turbine creating electricity. Now, in the previous section, we talked about ways you can generate current without a battery. Okay, so we can get a current by changing the magnetic field. For instance, moving a magnet towards or away from coil, or even just changing the strength of an electromagnet near a coil. You can also create current by moving a loop in or out of a field. You can also create current by rotating a loop with respect to the magnetic field. This third one, that third one there is how a generator works. As the loop rotates, it's cutting magnetic field lines to induce current. Now, this isn't going to be a very good drawing, but so let's say this is a loop of wire and I've got it hooked up to an ammeter. If you were to rotate the loop inside of your magnetic field, as it rotates, it cuts magnetic field lines, and as it cuts those magnetic field lines, it's going to create current that you'd be able to measure. So the motion changes into electricity. Now, there are different types of generators. Many of them generate alternating current because that's what so many of our appliances use. And because alternating current changes direction, it would vary like a sine curve. So if I were to graph the current over time for alternating current, the graph would look something like this. Positive is one direction, negative is another direction. And as it switches back and forth between positive and negative, it gets stronger and weaker. So if we think of it this way, this line here is 0. So it gets really, really strong in the positive direction, then goes back to 0, then it goes and changes direction. Gets really, really strong in the negative direction, then goes back to 0. And it just keeps going back and forth between strong positive and strong negative. And in an alternating current generator, there is a loop of wire right here that's connected to some rotating rings called slip rings. And these slip rings will allow the current to change direction as the loop rotates. It is possible, though, to convert an alternating current generator into a direct current generator by changing the arrangement of the rings, by replacing the slip rings with this piece called a commutator. I think I'm pronouncing that right. It's able to produce current that only goes in one direction. So for an AC generator, your current over time would look like the sine curve we drew on a couple of slides previous. Again, going between positive and negative, changing strength as it does so. But for a direct current generator, the current is not going to change direction. So it's not going to go to the negative side, it's going to stay positive. But within that, it's still going to get strong and weak. So 0 to its maximum, back to 0, and then just going to keep going in the same direction. So it looks more like that. So your current stays going in one direction, but gets stronger and weaker as it does so. Now, motors are kind of the opposite of generators. Motors take electricity, electrical energy, and changes it into mechanical energy. So for instance, let's take a fan as an example. A fan, you plug it into the wall, it takes the electricity from that outlet and changes it into mechanical energy as it spins the blades or rotates the fan back and forth. So we get current supplied to the loop by some source of EMF, some voltage source. Could be a battery if it's maybe a handheld device or something like that, or if you plug it into a wall, the voltage is being supplied by the wall outlet. And as we get current going through the loop, it creates a magnetic field in the loop, which interacts with the magnetic field of magnets already in the motor. So the magnetic field of the loop is attracted or repelled by the magnets of the motor, which causes it to spin. Now, I actually have an example of a simple motor. Now, what I've got here, I don't know if y'all can quite tell. Let me see if that helps. I've got a piece of black foam that I've got two metal posts stuck in. You can probably see it better if I do that. I've got a ring magnet and some copper wire that's been wrapped into a coil. Now remember that copper is not magnetic, okay? I'm going to put the magnet between the two posts here, and I'm going to put the coil in between, or have it suspended between the two posts. Now, just to show you, well, come on now. Sometimes I'm going to have to kickstart it. That I just want to prove to you that as it is right now, it eventually slows down and comes to a stop. Now, another thing I've got is a 6-volt battery and some alligator clips. And what I'm going to do is I'm going to touch the alligator clips to the 2 posts here and then connect them to my 6-volt battery. When I do that, I'm not done it yet. When I do that, it's going to create current through this coil, which produces a magnetic field inside the coil. It'll get attracted or repelled by the magnet sitting underneath it, and it'll start to move. Now, sometimes I have to give it a head start because I haven't quite gotten enough, a little bit too much friction, but there we go. Well, of course it's not going to work when I'm videoing it. Never fails. I think it's a law of physics that if you want to do a demonstration, it's going to fail at the worst possible time. And it's still giving me some trouble here. Alright. Alright. Yep. Never fails. Alright, y'all. There we go. Now it works. So, now that I've finally gotten it to work, you can see that the current creates the magnetic field, which interferes with the magnet I put underneath. Alright. I think that was it for this section. Let me double check. Yes. Alright, so that's it for this video.